you can all see that okay. Just hit me up in the chat if there's any problems. And as Ian said, I'm a generalist software engineer by background, so I'm not really the most data science native. So take my views through the lens of someone who's got a background in software. And if I ever skip over something that you think could be better explained, just feel free to jump in chat and ask me to clarify. I thought I'd start off this talk with a question to get us in the sort of right frame of mind, and also maybe a fun way of figuring out how much people have hacked around with Linux systems. So Amy, if you could run the poll question. This is a bit of trivia. If you've worked with Linux a lot, you'll probably be quite good at this, but which directory on a Linux system would you expect to find your system's log files? So it's in the bin directory, the lib directory, the var directory, or the etc directory. Let me just give a minute or so for that to come in. So Amy, I'm not sure if I should be doing some on my end, but let's see if we get results. Okay, cool. So quite varied. The most popular one is var. So if you thought it was var, you're correct. To go through them, so bin is where you'd have the binaries traditionally. So your tools, like your CLI tools. Lib is where you have your system libraries. Var is where you have files that change a lot, and log files will be included in that. And then etc is for config files. And I'm not surprised to see that the majority of people didn't quite get it right. And I think it shows that there's a lot of sort of historical knowledge that might be in the process of going away. And this talk is about the types of skills and technologies that I think we should back looking towards the future. So before we get into this, I want to talk a little bit about DevOps in general, because it's something that I've become a really big fan of learning to do better. And I want to tell you why, and also explain a bit about my career so far and how I got to this point. So my sort of formative experience with DevOps, I'd say, was when I was at University of Bath. So in 2014, I actually took the Advanced Compilers course, and I found myself way out of my depth. There actually wasn't an introduction to compilers course. And there was basically a 12-week coursework, which was most of the module in order to, where we had to create a compiler from scratch in C. And about 9 or 10 weeks into this course, I realized that I was about to fail it because my compiler didn't work. Every time I changed a bit of code, I broke everything else, and I was exhausted, and I had other things to be working on. I didn't know what to do. And I went through one of those moments where you just say, you know what, I'm just going to start from scratch. And I thought I'd try something that I'd never tried before, which was writing unit tests and test-driven development. And I was really surprised about what I found. So almost naturally, I started saying, in the next 2 hours, I'm going to implement this little bit of functionality. I would write a test, I'd write a little bit of code, and it would just sort of work. At regular points, I would hit run on the tests, and I would just know that I was making bits of progress towards my goal. But the thing that surprised me most is that I was using less cognitive energy. It was very mechanical. I would decide what I want to make, and whilst I was making it, I was using so little brain power that most of my concentration was thinking about what am I going to make next, and I found myself more creative. And it really broke a sort of preconception I had about testing and DevOps, the idea that it's this sort of boring, process-driven, dogma, things that you have to do. And I found that actually it was something that made me able to build faster. And I became quite excited about it. Maybe I got a bit too fundamentalist about test-driven development. But over the next couple of years, I found that it was a really useful skill. And so fast forward to 2016, I was working on Prime Video. And in contrast to me working on my compiler on my own and breaking it every time, I was amazed to see that 10,000 people could work on this single product, and there were millions of people using it, and it just worked. Sometimes we'd break things, but the system as a whole, the sort of hive mind of this gigantic team was self-healing. And if something got pushed into production and it was bad, you would find out so quickly that it was not working properly, and the tools would just help you roll things back. So the infrastructure was fantastic, and it led to AWS in lots of ways, the tools that we were using internally. And it, what I saw there was the perfected art of creating service-oriented tools, something which we've had to do many times over the last 20 years, building websites, building apps. This is software that is focused on the idea of a user opening an app, a bunch of services being called, and then the user being able to complete the task they wanted to. So at Prime Video, I learned that we've just absolutely mastered that. It can get a bit better probably, but websites are reliable, and the practices we learned in the process are helping us do that. But what happened next is that I actually got a job which was more in the data space. I got really excited about AI and all of that stuff, and there was a local company here in London called Improbable, and they were working on simulations. So the idea is that if you have a lot of information about how a city works, you can model it. So let's say you know about a population, you can build traffic models, and then you can help people that are designing road networks create policies that prevent traffic jams. And this really got to the core of what excites me about data science and AI. It's the idea that you start with all this information you have about the world, and then you enrich it and you use it to make better decisions. Unfortunately, what I also learned is that this is a totally different type of application to build than a web service. And overall, I feel like we were so much less productive in building it. Whereas at Amazon, you could have 10,000 people building a web service and it works well. Working on a data pipeline, you can have 10 people on it and progress can grind to a halt. And I wanted to figure out why that was. So I really dug into what I feel is not productive about working with data pipelines and data science in general. So let's start with what's different about running a data science project. If you're working on a website, you're mostly thinking synchronously. Someone opens an app, you call some services, they get a response. But with data pipelines, you need things to happen ahead of time. It's not about the user, it's about when the data source changes and you need to recreate your models, recreate your dashboards, and prepare the experience for the next time someone opens the app at the end of it. So it's highly asynchronous. The next thing is that it's less deterministic, meaning that traditional testing methods, they just don't work so well. You run an algorithm twice, you get two different results. They're both okay. And the last thing you want is to be overly specific about what something should return. But I think the things that are most different about data projects that I found out Improbable are the tooling and the personnel. And they come from a scientific background, meaning that you're using matplotlib, you're using Python, something which was originally intended to be for people to learn programming. And it was the first language I learned. And it was so popular in universities, and the tooling around data modeling and data science got so effective that we now use it everywhere. And that leads to some consequences that I'm going to go into. But even more interesting than the tooling are the people. At Amazon, the team was mostly computer science graduates and people that had lots of experience running websites and apps. But at a company like Improbable, or a company that's doing a lot of data science, the great thing is that you've got people that are really well trained in statistics, and hopefully they've come from a domain that is relevant to the problem you're solving. So maybe you're working with people with biology PhDs or physics degrees. And as a result, a lot of the tooling that we use to make projects run effectively is not really made for people with a background that are now relying on it. And so around this time at Improbable, I came across this quote, and I don't really want to dig into it too much. I think if you are watching this conference, you probably have seen it before, but people are saying that data scientists waste 80% of their time. So in hindsight, it turns out that this is mostly about people wasting their time data cleaning. And I don't really want to get into too much whether I think data scientists should have to manually clean data or if the tools for automating it are good enough. But I want to tell you that my reaction when I saw this quote was that I feel like it must be true. And it's not because of scope creep in the job. It's because the tasks that you're trying to do when you're contributing to a data science project feel inefficient. It feels like you should be able to 5x or 10x your productivity. And when you think about it in terms of being able to 10x your productivity, you could even say this quote is quite conservative. So why do I think that productivity can be improved so much? I look at contributing to software projects in terms of a really high level loop. So you're given a task. Maybe you're working on a dashboard and you've got to add some extra information to it. Maybe you're working on a chatbot and you need to fix a bug. But it starts with you getting a repo and you need to pull the latest code down onto your development environment. It could be a laptop, it could be a Jupyter Hub. Before you make your change, you've got to really figure out, is this working in my environment? And everyone's got their own way of doing it. If you're really organized, you might be running things like PyTest. If you're less organized, you might be hitting run on a main method somewhere and just generally getting a feeling of if this thing is working. Once you feel like it's working, you can make your change. And before you push your change into somewhere that people can benefit from it, so back into the repo and maybe deploy it so that it's available to whoever's using your tool, you need to check that it's not going to break everything for the rest of the team and ultimately break things for people that need what you're building. So you validate your change and you push it. And whilst we focus a lot on the making the change part of the loop, I believe that these validation steps are super important, and they're actually a bit of a black hole of time when you think about it. So how do you validate that it's safe to start making your change, that your dev environment is doing what the repo says? Well, you need to run some sort of build process. And build is a slightly archaic term. It's around the idea of building binaries into libraries. With Python, it's more about installing dependencies and just feeling like the thing is working. So you need to validate your environment by building it. And then after you make your change, you need to do the opposite. You need to validate, you need to build your environment again and check that it will work in your team's environment. And maybe you have a continuous integration server for this, or maybe you do it locally. So this is great, apart from the fact that it's never great. It's almost always painful when you're pulling in changes from your team on a Python data science project. So here is an error message. I got it from Stack Overflow, and you've probably never seen this error message before, but I can almost guarantee that if you've been working in Python for more than a few weeks, you've seen a lot of error messages like this. And when you see an error message like this, it means that you're not going to start working on your change because you need to figure out what is wrong with my laptop right now. So how does this work? How do you resolve this? Well, you usually go to Stack Overflow, you paste in the error message, you get a bunch of tips from people, you ask your team, is it okay if we use a different version of this package? It's not working on my laptop. And maybe you can resolve it within 30 minutes to an hour if you're lucky. But I want to tell you what I've seen this type of error message do. I've seen two terrible things happen off the back of people not being able to install dependencies. One is I've seen someone resort to getting a new laptop because the source of the error was so deeply ingrained in the system that they really couldn't figure out how to fix it. Maybe it was caused by installing pip using sudo, or maybe it was just something to do with how the laptop was created in the first place. But the point is that random details about how your OS X was set up might stop you from working on a project that really should be decoupled from this fact. Now, the other terrible thing I've seen happen is people say, you know what, I can't install this thing on my laptop, so I'm never going to run it locally. And they basically said, I don't want to pay a fixed cost for fixing this issue. I don't want to spend a day figuring out how to install this thing that won't install. So instead, I'm going to basically never run it. And then you pay a variable cost. Every time you want to make a change, you risk shipping bugs, you risk disrupting your team. I'm just going to see if I can get into this Q&A for a second. Okay, cool. So this type of error message has happened in lots of ways, and it really is a thorn in the side of anyone that's working on a project. And if you've got someone new starting the team, they're almost always going to need someone holding their hand and getting started with it. But that's not the only error you get, because when you pull down a new version of code from a repo that you're using, it's really common that some data files that need to be installed locally on your laptop are out of sync with the code. And so you'll often just see errors like file not found, and you're really not sure why. Or you'll see that you do have a file, but it's missing a column that you need. And there's always this question, is this a problem with the code or is this a problem with my laptop? And the cost of this can be pretty serious because, you know, one of the projects we're working on at Improbable, it involved running a pipeline that took an hour to run just to generate a data file so that you could use that data file for working in your local environment. And if you're not sure why you're seeing an error message, it can get tempting to just say, oh, I'm going to rerun all these data files, all these data pipeline steps. Or the alternative, as I said before, is just not testing at all and just saying, I'm going to make my change, I'm going to push it, and we'll just see what happens. And then a problem that existed for you is now a problem for your entire team, which might be 4 people, might be 8 people, but the larger the project, the higher the cost. So anyway, if you're diligent and you manage to install all your dependencies and get all your data files working, then you'll probably start finding real bugs because all code bases have real bugs. And a lot of the issues I said earlier about asynchronous, stochastic parts of the code base mean that it's so hard to test. So what happens? Well, someone comes along and says, someone like me comes along and says, we need to, you know, improve our DevOps practices. I'm going to set up continuous integration. I'm going to write a load of tests, and we're never going to be blocked by these issues. And next thing, the code base starts filling up with bash scripts. And when you push your code, the bash script runs, it tests a load of stuff, and then you get really long log files. And I think this is one of the places where I've started asking myself, is the cure worse than the disease? And by that I mean, for me, I'm okay with reading gigantic log files, but what I took a really long time to appreciate is that after 7 years of software engineering, I've developed this extremely niche skill, I think, when we look at it, of being able to read a 1,000-line file and pick out the 1 or 2 lines that are actually important and ignore the other 999 lines, which look important, but are actually completely irrelevant. And so in the process of trying to fix all these productivity issues in the repo, you end up alienating a lot of the team that maybe have come out of a biology PhD and have learned Python, but haven't spent years running websites and trawling through log files. And you end up with a very unbalanced situation where if I'm experiencing problems pushing code and having error reports, I know how to fix them because I can get through the log file and I can fix the bash script. But if you're a Python developer and you want to push a change, you end up with this gigantic file with logs and a bash script, and you really don't know what you need to do to fix the problem. And where does this end? Well, it ends in the team having single points of failure, where the people that are the most skilled up in DevOps are so relied upon by the others to get work done that it becomes a little bit dysfunctional. And so thinking back over how we got to this place, I realized that we want to have a situation where everyone on the team is able to work well with the team's infrastructure, where you're able to validate your changes and you're able to validate your environment when you pull down someone's code. And I think that eliminating bash and eliminating long log files is a part of that. But overall, we're going to have to think about the whole stack we use in DevOps as a whole. So thinking about this from first principles, I believe that if you're working in a Python data science project, you need a few things. So you need a virtualization layer so that you can actually install all your dependencies in one place. The most common virtualization layer is virtualenv, which is actually really minimal. And we can probably do better than that. Now, secondly, we need to start keeping a lid on how much bash is in the actual project, because bash was never really intended for gigantic scripts. It's mostly useful for the command line. And if it's, you know, people say if your bash script is longer than 5 lines, it should probably be written in another language. So we need to find a way of keeping that under control. But finally, I think we need to start figuring out this problem with getting information out of log files. How do we make it so that you don't need to have years of experience reading logs to actually diagnose what's wrong with the build process so that you can ensure your work is reproducible? So I've done something which I don't usually do. It's a little bit cheesy, but I'm coining an acronym, and I call it the CAN stack. And it betrays my belief that there's not a single tool, a single practice that's going to fix this, but I think a combination of tools can really help us move towards Python projects where everyone is empowered to make changes effectively. So the C in CAN stands for containers. Containers are extremely well used for hosting websites, running, productionizing things, putting it in the cloud. What they're not that well used for right now is for making dev environments consistent. So my first belief here is that we need to look at virtual env and say, is a virtual env really virtual? Does it really help you install things in a way that it doesn't matter what's beneath it? And the answer is no, because of the error messages that I was showing you. If you've got something funny in your OS X, if you change something in one of your random directories, your virtual env is not going to help you, because that only helps with Python packages. Just check Q&A for a second. Cool. So, sorry, 1 second. So if you want to have, if you really want to get to the bottom of the problem of installing dependencies in a way that doesn't have things randomly break behind the scenes and end up with you getting a new laptop or searching through Stack Overflow for hours, we want operating system level virtualization, something which gives you your own bin and lib directories and ultimately lets the whole team work from as if they were on, let's say, an Ubuntu virtual environment. And this isn't just useful for getting the whole team on the same environment. This is also useful because if you're running continuous integration, if you've got a server in the cloud running your tests, using a dev container can actually let you have the exact same environment that is used when the tests run, meaning that you get total reproducibility. So what you can see on the screen here is something pretty new. It's something that Microsoft has been building, and it's dev container support in Visual Studio Code. So a couple of years ago, it was really difficult to use containers as virtual environments. But now with a few lines of config, you can actually say, I'm not going to use virtual env, or I'm not going to use pipenv, I'm not going to use conda on its own. I'm actually going to have a remote container that's going to sit beneath everything that I'm doing in Python, and I'm still going to be able to code on through VS Code just like before. And so this is exciting because you can run it in Visual Studio Code, but what they're actually doing is making a product called Code Spaces, such that if you're set up on GitHub, you can have one of these files that lets you just spawn a container in a browser window, and it will essentially make it feel like you're just loading a web page. You don't have to install things because they've been installed ahead of time. You just sort of open the window, all your dependencies are there, and you can start coding. So the second tool in the CAN stack is Actions. And Actions is, I'm referring quite loosely to GitHub Actions, but what I really believe is that there's a pattern, and this pattern is quite powerful. So GitHub Actions was released last year, and I believe there's another similar tool which Circle CI has called Orbs. And the general idea is that if you need to set up a build process that runs in the cloud, something which you would manually do on your laptop, like setting up Google Cloud Platform, using CLI tools is super difficult. You end up pushing something, realizing that it's waiting for user input in the cloud and it fails, and then you have to push something again. And the GitHub Actions pattern is basically saying people are porting common command line tools and making it so that you can install it in your repo with a little chunk of YAML. And as a result, what would have taken a really long time to figure out how to set up with a bash script is now a few lines of config that lets you hook up your repo to Google Cloud Platform and pull down your data dependencies and start testing against them automatically every time someone pushes. So the final part of the CAN stack is something that I'm personally quite excited about now. I feel like I've approached notebooks from a different angle to most people, but I believe that they are creating a load of opportunities in DevOps that we should embrace. So to start off with, Notebooks are super accessible. If you're in a data science team, it's probably one of the tools that everyone can agree that they're able to use, although everyone can agree that they shouldn't be used for everything. So my sort of belief with notebooks is that we can do the opposite thing that I'm suggesting we can do with containers. Containers are known to be useful in the cloud for running web apps, and I believe that they can be also circulated to use on a desktop to make things consistent with the cloud. And we can do the opposite with notebooks. They're super easy to use on your desktop in your dev environment, but we can also automate them and use them as scripts to run in the cloud. And the reason why it's so powerful is because one of the massive problems I said with logging is that there's so much information, you're not sure what to pull out. But with notebooks, you've got a little bit of code and then a little bit of output. And suddenly the person who wrote the notebook, if you automate it to run in the cloud, debugging it feels very similar to how you debug on your laptop. You can upload the output notebook that's been run and view it like this. So this notebook that you can see on the screen here is probably not like a notebook that you've written in the past, because it's not really doing exploratory data analysis. So this is something that we've been working with a few people on GitHub on, and it's setting up an API. So it's saying there's a Python client for an API. We need to make sure that we can access it with a token. So we're setting it up in cell 1. And then we're using a little helper that we've written, and we're installing a custom dependency on line 3. And the great thing about the script is that you can run it on your local environment, you can run it in the cloud, and you can see the logs, and they look the same from both. So yeah, notebooks are something which are opening up a lot of opportunities in DevOps. I think it's a really interesting progression in the user experience of coding and software engineering in general. And if you want more information on it, you should look up some of the Netflix blogs where they talk about how they run hundreds of thousands of jobs per day, and they're all in notebooks because of how debuggable they are afterwards. What's even more interesting to me is where this is going next with notebooks. So Visual Studio Code has a new early access product called Visual Studio Code Insiders, and they're acknowledging that notebooks are often replacing the command line in how we do things. But unlike the command line, they can actually return HTML. And as a result, you can start integrating much more powerful tools into notebooks than you'd use from the command line. So this is something which you can try out in Visual Studio. And you can basically look up your GitHub issues without ever leaving your development environment. And the longer you can stay inside the development environment, the less you have to context switch out into Google Chrome where you're looking things up. And so this is something which I think we're going to see a lot more of. And a lot of developer tools, I believe, are going to start getting integrated into notebooks in this way. Okay, so I just described 3 technologies: containers, actions, and notebooks. And I want to, I believe they're going to work together in lots of different ways, but I just want to give you an overview of how, at a high level, they work together. So imagine you've got a dev environment, you're working on a Python library, and potentially you've written a Docker file for that, so that you can test it inside there. For example, there's a popular tool named Binder, which I'm sure you're familiar with. And that's actually an alternative to writing Docker files, but it lets you specify an environment with like requirements.txt. So you've got your Python library, you've got your requirements, and you have some example notebooks. And example notebooks are extremely powerful if used as integration tests. And so thinking about how we can set up a better build process, I don't think we should start saying we need to rewrite how we test code. I think we can look at the setup of a normal project and say, what if we push that to the source repo and use GitHub Actions to build a container from it and run the notebooks to test it? So you've got your action runner on the right, and that's kind of complementary to your dev environment on the left. And the kind of things, the kind of time-consuming testing tasks can be picked up by the action runner. It can build containers for you. It can run notebooks and test them and upload them somewhere where you can view them. And now you've got a container registry where you've got working Docker images that have all of your dependencies pre-installed. And that means the next time someone wants to run your code, maybe you've got a new team member, maybe you want to let someone else try what you've built, they can actually use that container registry and pull down a working environment that your code is proven to run inside. And as a result, you're not going to have them coming back to you saying, hey, can you help me get this running? I can't pip install this. I'm getting this really random error message. So when you look at it on the whole, you get this idea of a repo, and then on top of the repo, you've got this working container layer, and you first experience, you actually access the functionality inside the container by going through notebooks, either in an automated environment or in a desktop environment. So I want to explain what I've been working on with Treebeard for the last few months, and it's related to the idea that we can use containers, actions, and notebooks to vastly simplify build processes. So I believe that Treebeard is actually the easiest way of automating notebook tests, and I've really focused on small projects where there's not many DevOps sort of tooling, there's not much DevOps tooling in place, but you've just got some Python scripts with functionality, maybe training models, maybe creating dashboards, and then you've got notebooks which are accessing that functionality and perhaps testing that functionality. So firstly, I want to recognize two fantastic libraries that are useful if you're working in this space. Repo to Docker is a library which lets you create Docker images without knowing how to write a Docker file. And this is really important if in your team there's not much experience with Docker and you don't have the bandwidth to allocate people to learning how to use it directly. So Repo to Docker is actually the library which underpins Binder and takes a given Python project. It actually also works with other languages, but it can take a Python project and turn it into a library with a working Jupyter environment and everything installed. And once Treebeard has built the library with Repit to Docker, it uses Papermill, which is the notebook automation library used at Netflix, to run all of the notebooks in the library. And as a result, if you've got example notebooks about how something should work, or if you've got tasks that need automating, or if you have scripts that pull in data in the form of a notebook, it will essentially complete the environment for you. It will say, we've just built this repo into a Docker container, and then we're going to validate it by running the notebooks and checking that the next time someone uses this thing, they're going to be able to use your code. So the actions part of this is that maybe, if I was a bit more backward looking about it, I'd say we need to really focus on the command line interface for Treebeard, because there is one. But I believe that we should be investing in future tools. And the main way of interacting with Treebeard is actually on GitHub Actions. GitHub Actions only came out a year ago, so I expect that most people won't have experience with it. But to give you a high-level overview, it lets you automate tasks in response to repo events. So if you've just pushed your repo, you can see here that this action is configured with a couple triggers. So firstly, we're saying on, meaning that we're about to specify what triggers are going to invoke this action. And we're saying a push event without any parameters, meaning that if you push to a branch, or if you push to a tag, it will activate this action. Alternatively, if you there is a schedule, meaning that if you have data being updated somewhere out of the loop on a weekly basis, you can run it against a new version of that data and check that it's still working. And what does this action actually do? Well, the key is under jobs, looking at the steps. So there's two actions used here which are built by GitHub themselves, and that's the action to check out the repo onto the action worker that's automating things for us. And then there's the setup Python, which will install Python onto the worker, which can be a surprisingly buggy experience if you're just trying to do it by using apt-get install. And finally, what this job does is it uses the Treebeard action, and the Treebeard action will build the container and then test the notebooks. And within one line, it essentially gives you a build process where you may not have had one before. And so this has proven useful for some of the users, either because they've literally had no experience with continuous integration before, and they want to test all the notebooks they're using for a course or examples in the library. But even for experienced users, it's likely that they have PyTest set up, but they've never tried testing the notebooks that they're showing people if they're using Binder. And so it can work as the first pipeline that you're adding to a project, but it can also work alongside other pipelines that you've got set up. So, getting back to logs, one of the things that I've been really focused on is log readability. And so the first thing is that we're never going to be able to eliminate logs in total, but we can compile the most useful information and leave it at the end. So this is the end of a Treebeard run, and it shows you which notebooks passed and which notebooks failed, and it actually pulls out a little bit of information about the cause of a failure so that you don't have to go trawling upwards through the log file. And another improvement that we made a bit after releasing it initially is making it catch missing dependencies, because we don't always remember to add all of our dependencies to a Python project. And this goes back to the sort of Python not being necessarily an enterprise grade environment where installing a dependency automatically adds it to the repo. And we need to fix bits of legacy here and there. So if you've forgotten to list 5 dependencies, you'll catch them all at once and resolve what can be a frustrating experience of running into an error about one missing dependency and then coming back and adding them one by one until you finally get it working. And I think, as I said, with log readability, the thing that I'm most excited about is that we've started offering a service to upload notebook log files. And if you've ever, even for people that are used to reading log files, I think that something like this is a breath of fresh air, where you can see what chunk of code ran, you can see standard error in red, you can see the standard output, and for many tools, you'll get HTML output. And this is just a total difference to the kind of experience of debugging a remote job that's happened in a traditional sort of command line environment. So to get back and summarize, what I'm suggesting is that we look at containers not just as things that run in the cloud, but things that can help you have a super bulletproof virtual environment on your laptop. I think we should be trying to reduce the amount of bash we're writing by using actions to set up CI. And I think we need to look at the opportunity with notebooks as a sort of revelation in the user experience of software engineering, and saying, how can this help us eliminate a lot of the complexity about working with automation and running things in the cloud. And I think when you put all of these together, you can start to see perhaps a layer that goes on top of a lot of Python tooling, which can be buggy if used on its own, and saying we can actually build something a lot more solid on top of it, which works in all environments. So I appreciate I've gone through a bunch of different technologies. I reckon that there's probably a lot of questions about how it can work in practice, and everyone's project is different. So I'm really interested to hear, if you're thinking of improving DevOps around your Python project, challenge me on my worldview and help me make it better. And so I'd say the first thing to do though is to check out Treebeard Tech /Treebeard, which is the project on GitHub, and have a look at my sort of reference implementation of this model, and accept that it's actually just a reference implementation. It's not the be all and end all. Also, you can chat with me on Twitter. We have a Git community. And I want to give a shout out to a community that I've spent some time in recently, and I think is really onto some good stuff around data science DevOps, which is the research software engineering community. And you can go to the URL there and go on Slack, and I'm in the workspace, and there's lots of people doing some good stuff at universities and research institutions. So with that, thanks very much. I can hand it over for questions.
Hey, thanks, Alex, for that talk. Certainly informative, and there's certainly a lot to think about. I'm probably one of those data scientists who's come from the science background that you talked about, and there's enough time wasted that comes from testing all the options that arise from the stochastic nature of the algorithm sometimes. So, but I've certainly spent many hours in the black hole of conflicting packages, so that was interesting. We can dive into the questions now. The top ones, like you've already sort of preempted, was there was a big queue on how to get started with CAN, and it's partly answered, but it remains top. So if you'd like to say perhaps a little bit about you said briefly at the end of the talk about people should go to the Treebeard repo, and maybe remind them of that, because the top question is, how can you recommend people get started if they're interested in the CAN stack?
Yeah.
So just give them a bullet point list that they can jot down or whatever, I guess.
Yeah, for sure. So I think the key here is that we're talking about 3 technologies that work well together, and it's likely that your setup needs one more than the others at any given point. So if you're really struggling with dependency management, I would say start looking at dev containers. So Google dev containers and look at the Visual Studio docs for them, and figure out, do we have enough experience in the team to start writing Docker files that we can use as dev environments? If yes, then it's great. If not, you might want to try approach more on repo to Docker. If your team is quite heavy on scripts, if you've got a lot of scripts, and I've started calling them repo junk in a way, because repos can quickly fill up with all sorts of scripts with poor documentation and they're quite buggy, then you might want to start looking at notebooks more and saying, is this going to make it more accessible to the team as a whole? And if you've already got a really heavy CI setup, and you've written loads of bash scripts, I think actions are super easy to get on board with. And I'd start looking at, can we start making our continuous integration environments more similar to our dev environments by using some of the actions, for example, that can set up Google Cloud. Okay,
great. So just following on from that, Mark Peterson, I believe, probably I'd say, would there be some kind of standard way to structure tests when writing them in a Jupyter notebook instead of something like PyTest?
Sure. So I think the main paradigm shift that I believe in is looking at tests as as ultimately less amenable to automation, unfortunately. So I think that whereas before you might look at unit testing and say, I want to check this class does this thing, I think we should be more focused on high level sort of getting value for time integration tests. And what that means is looking at the way you'd write an example notebook for a repo if you're going to teach someone about how it works. I would look at that more and say, how do we write really good examples that will walk through all these different bits of functionality in our code base, and automate it so that we can put a couple of assertions in. And for the things that we can't assert, things to do with graphs, I think we should just make sure that that notebook can be uploaded and people can view it, so that if you suspect there's a bug, you can actually just see, how did it run recently? How did it run in the last few weeks? And so I think like the PyTest approach is great for if you're shipping a game or if you're shipping a website and it's extremely sensitive to millions of customers relying on something. But if you're working data science projects where you're trying to build a dashboard for an internal team, I think like you don't need so much focus on unit tests. You need an integration test that helps the whole team basically stay productive.
Okay, great, thanks. Well, I guess following on a little from that, Matthew Sharp asked, could you give some examples of the type of tests you would write and include as part of a CI pipeline? Obviously, yeah. Briefly.
Yeah, sure. So the first thing I want to say is that I'm not saying we should never write unit tests anymore, but because the level of testing can be quite low in data science projects in general, I would start with something really high level. And so, for example, on Treebeard, I've written a notebook that will import the Python API, and it essentially is like a README. I call it an interactive tutorial. So actually, if you go on the GitHub repo, you can go on Binder, and then it will teach you how to use the internal Python API. If you're thinking of developing if you think of hacking on the project, it will teach you how to use it. But it actually is really representative for the type of testing that I think we should be doing, which is saying, I'm going to import some stuff, I'm going to run one thing, and then I'm going to run a different thing. And that's going to make me 80% sure that this repo is working. And if you actually need 100% confidence in the repo, I would then say, start getting into PyTesting.
Sure, thanks.
And so in terms of an example, I can probably just paste in the actual notebook itself. I can actually put it in Q&A at the end just because.
Sure, that's fine, that's great. Now, you went into this a little bit in the talk, but apologies for the pronunciation again here, but Leis Carvalho asked, he asked, would any of the issues that are not solved by virtual env be solved by use of Conda? And then subsequently you talked a little bit about it. But roughly, you know, I guess then his follow-up to that would be, you know, what fraction of those MyEnv1s are still left when you're using a Conda, use of the sort of Conda system?
Yeah, sure. Okay, so the first thing I'd say is that I actually wrote a blog post recently, which I can link in the chat. And sorry, that's Lewis's question.
Yeah, yeah.
Yes, so I wrote a blog post about that. But what I'd say is that the main difference between virtualenv and Conda is that Conda helps you bring native dependencies into your virtual environment. So with virtualenv, it's quite likely that if you install TensorFlow, some of the libraries are actually just coming from your laptop, coming from the operating system, meaning that they're going to be different for the whole team potentially, and you'll get these really insidious little errors. With Conda, it's more likely that your binary dependencies, your like GPU libraries are consistent because of the way Conda packages are built. But even with Conda, there's tons of things in your operating system which affect how it works, environment variables and you know, sometimes like transitive dependencies and other libraries. And I came to the conclusion that you do want Conda and you do want pip, but you want to be using them on top of Docker if you're really serious, if you really seriously feel like this problem is a thorn in your side.
Oh, sometimes it can be like a ghost in the machine for sure. You can spend so long. Okay, thanks. Alessandro Rizzo, would you agree that when it comes to testing data-intensive applications, we need a conceptual shift from thinking that tests are only meant to keep the system in a functional state to thinking that tests also need to keep the database in a consistent fashion? So yeah.
I'd start by saying that I think it really depends what you're building. The idea of saying like you're keeping your database in a consistent state, I think maybe I disagree with the premise that you've got this database that is sitting there live. I like the idea of very functional environments. And one of the reasons why I think like we should start using notebooks for scripts is because I think we're going to need a lot of scripts for constructing data dependencies. So when you want to test something locally or in the cloud, I wouldn't say it's about keeping a database in a state. I'd say more likely you want to create a database from scratch with all the things you expect to have in it, and use that as a really sort of functional starting point. If you've got a database sitting somewhere with a lot of information in it, that's always going to be a weakness in your setup. There's always going to be the risk that someone breaks it and everyone else is like, what do we do about them?
Sure. Okay. Oh, crikey, another difficult one. Megana Bandaru has asked, using notebooks for testing is a great idea. Can I reproduce this concept in production environment as well? If so, how can I incorporate this into my machine learning pipelines? Where does it fit in?
Sure. So there's actually lots of tools that are supporting notebooks quite natively now. So when I was talking about Treebeard, I'm mostly talking about the build process where you actually establish that an environment is working well, and you can use it for little bits of automation. Some people have. But overall, if you're doing something like in real production, you're going to want to look at using Papermill as the starting point. So you know, that's basically the most flexible tool for running notebooks in production. It's got a Python API, and it can actually read and write from S3. So you can essentially get all your logs delivered to S3, and you can view them through some sort of dashboard. But on top of that, there are even higher level frameworks that work well with notebooks now. So one that I've admired for quite a while is called Dagster. And Dagster essentially is a bit like Airflow, but it's a lot more Python native. And it has a little add-on that lets you use a notebook as one of the steps in your graph. So that if you're setting up like an ETL pipeline, rather than having a Python script move data from database A to database B, you've got a notebook that can be audited later on.
Wow, great stuff.
And sort of broadly speaking, I'd say that if your code is a script that sort of runs from top to bottom with minimal parameters, then I'd say that a notebook can fit into that environment. But you know, I'd caveat that by saying like we're kind of in the early days. Notebooks weren't made for this, and there's a lot of retrofitting going on in order to reap the benefits there.
Okay, great stuff. Thank you. We have, there's one from Yafim Shoof. I don't know whether you're familiar with comet.ml. There was a question about comparing and contrasting your approach. Perhaps you'd prefer to respond to that if you're not familiar with them after you've checked their, what they're up to. Adam Tomlin again asks, what type of people or teams could benefit the most from rethinking their approach to DevOps? I'm going to preempt it and guess that you say the ones with the most sciencey types in them, but yeah, what are your thoughts on that?
Yes, so I think one thing that I'm really trying to guard against is sounding like disparaging about the ability of scientists to do engineering, because it's, you know, the people I've worked with scientific backgrounds are incredibly capable with engineering. The truth is, it's the team that does not want to be investing in traditional, in the sort of legacy of traditional DevOps skills, because they feel like it's essentially like a diversion from what they're really good at. Those are the ones that I think should be looking forward and saying, we've got people that are great at Python, and so they can, in many cases, they can use Python instead of Bash scripts. They haven't read lots of log files and worked at sort of big internet companies where you get good at debugging systems. So notebooks are great. And also they already use notebooks. So, you know,
Yeah,
they can potentially like stay in Jupyter Lab longer and stay in Visual Studio Code longer. So I say it's the domain specific types and the multidisciplinary teams that I really want to empower here.
Great. And it sounds certainly like what you're developing there can fix a lot of time wasting. So Alistair Graham says, thanks for the great talk, and asks, so does using the CAN stack remove the need to know software such as Ansible, Salt, or Terraform?
In short, no. I don't think that this is like a panacea. I also believe that you'll still need to learn how to write Docker files in some cases. It depends on the project that you're working on. But I think that it is a way of thinking about like your build process in such a way that if you want to be simplifying things, you can use, like in the most extreme case, Treebeard, which I built, it can be used to automate a vast amount of the build process and leave some manual bits here and there. But if you're setting up loads of custom hardware like Dust clusters and stuff like that, you may find that it's still worth bringing in like really specialist people that are able to use Terraform and Ansible to set up that cluster for you.
Got you. Okay, I'll let you off the hook after one more question. It's a follow-up from Megana Bandaru. So just to finish off, what would you suggest for a beginner to create an E2E ML pipeline with some data science algorithm built and encapsulated in a Flask or some container? I'm presuming that this is going to be a way for you to suggest that she gets to your particular repo or the just offer a pathway for somebody who's got a project on the go right now that they would like to benefit from your approach.
Yeah. So I mean, like, I think that end-to-end machine learning pipeline is quite a loaded term. I'd say it does make me think of things like ML flow if you're actually doing experiment tracking. And it's slightly different to the idea of having a build process, which just helps you work in Python more generally. So if you want automatic testing, if you want the actual nuts and bolts of your code to work well, that's when I'd say look at things like Treebeard, for getting initial continuous integration set up. If you're looking at deploying a Flask app, that's a slightly different problem as well. That's what things like Heroku are for. And if you actually want to track experiments and try all these different combinations of parameters, you may want to try something like ML flow. So unfortunately, I don't really have one specific answer. As is often the case in data science, there's one problem which is constructing your pipeline. There's another problem which is deploying it in a way that lets people use it.
Amen to that, definitely. Okay, well, I think, we have a couple more, and we have a couple of minutes left. If you'd like another question, you can see them, I presume, there on your screen. If you want to pick up one of those, we've got 4 minutes left before the end of time.
Sure. So talking about like data and model lineage, I would actually say that this is in the same sort of space as machine learning tracking. My sort of area expertise is in generalist like software engineering, and so I'm a little bit below. I'm trying to focus on the actual like really frequent coding operations, pulling down code, installing it, running it, testing it. If you want to look at data lineage, you're actually thinking a little bit higher in the stack. You're thinking more about, it might be specific to your domain, but you're thinking about, is there like a database I need separately to attach on to my GitHub repo? And I don't really want to specify too much around that because I actually don't know a great deal about that.
Well, we can end it on that. And thanks for the interesting talk and limiting the comments to the sphere of competence. I got a lot of respect for that. I'd encourage anybody listening who is interested in finding out more or has further questions to reach out to you on the social media handles you've provided, and that the data science guys will put on the link with the YouTube video, which will be up this afternoon. So
yeah, definitely feel free to reach out, and thanks for having me, Ian. Really appreciate it.
Yeah, no, thank you. Well, I'm the guest host as well, so I've really enjoyed listening to what you had to say, Alex. Thank you very much. And to everybody else, enjoy the rest of the afternoon or evening or morning wherever you are. It's sunny in the UK, so we're going to go and make the most of it. Thanks very much.
Cheers.
Cheers. Bye now.